We're going to begin a process called factoring, and we're going to start with factoring out a GCF, or greatest common factor. Need to have a little bit of vocabulary here. Prime numbers. What are prime numbers? Prime numbers is any number that has exactly two factors, 1 and itself. 1 is not a prime number because it only has one factor. So my smallest prime number is 2. Then comes 3. 4 is not prime because it's divisible by 1, 2, and 4. 5 is a prime number. 6 is not prime because it's divisible by 1, 2, 3, and 6, so it has 4 factors. 7 is prime. 8 is not. 9 is not. 10 is not. 11 is. 13 is, and it goes on out like that. Okay? Prime factorization, you've probably seen it two different ways: a factor tree and a factor ladder. So for the factor tree, we are going to do 64. We are going to do prime factorization of 64. So in order to do that, think of any two numbers that will multiply together to give you 64. Well, I'm going to go with 8 and 8. Are either one of those prime? No, they are not. So we need to keep going. Think of any two numbers that will multiply together to give you 8. How about 2 and 4? 2 is prime, so I circle it. Okay, 4 is not prime, so I keep going. Two numbers that will multiply to give you 4, 2 and 2. There, we've got it. Okay, go over here, do the same thing. That's going to be 2 and 4. 2 is prime. That's going to be 2 and 2. Those are prime, so that's 1, 2, 3, 4, 5, 6. So that is 2 to the 6th power. All right? The other one is a factor ladder. So let's take the number 48. With a factor ladder, you start with the smallest prime factor, which is 2, and see if it'll go in there. It will. 2 will go into 48 24 times. Well, 2 will go in this again. So I keep going. It'll go into here 12 times. 2 will go into here again. That's 6. 2 will go into here again. That's 3. 2 won't go in there anymore. The next prime number is 3. So will 3 go into here? Yes, it will, and that's a 1. When you get to a 1 down here, you know you're finished, and there are your prime numbers right there. So that's 2 to the 4th power times 3. That is called prime factorization. Take something and break it down into primes. There's another kind of factoring. It's just where you list the factors. So let's list the factors of 48. Okay? Now, I've seen this done two ways. I do it vertically. I say the smallest number that will divide it into 48 is 1, and the largest is 48. I make sure that these two multiply together to give me 48. And then I go numerically. Next, it would be 2. 2 will go into 48 24 times. Will 3 go into 48? Yes. It'll go in there 16 times. Will 4 divide evenly in there? Yes. 12. 4 times 12 is 48. Will 5 go? No. What about 6? Yes. 6 times 8. The only number in between here is 7, and 7 will not go into 48, so I know that I've listed all of my factors. I've also seen people do the same method, but they'll stretch it out. They'll put the 1 here and the 48 over here, and then they'll start listing the factors as they go in, and when they meet in the middle, then they know that they're finished. Okay? So either way you want to do that is absolutely fine. Okay? It just makes it nice if you do it like this, and so that you make sure that you don't miss any. All right, now we're going to talk about a GCF, which is the greatest common factor. To find the greatest common factor, you are looking for the largest number that will divide evenly into both of them. I'm going to show you two methods. The first method is to list the factors of each one of these. Now, we already did this with 48. Okay, so with 64, we need to list those factors. Once you've listed the factors, you're looking for the greatest common factor. So they both have a 1 in common, a 2 in common, a 4 in common, an 8 in common, a 16 in common. So out of those, which is the greatest? That would be 16. That's method number 1. Method number 2, you list the prime factors. So what you do then is you make a little comparison box here All right, 64 is 2 to the 6th power. 48 is 2 to the 4th power times 3. You make sure that the factors are in their own columns. And then you only use a column that is full. So this is a full column. So I use this and I choose the smallest choice, which is this, which 2 to the 4th is equal to 16. So in either case, the greatest common factor is 16. Okay, the distributive property tells us that when we have A times B plus C, we get AB plus AC. We're using the distributive property kind of backwards to factor out the greatest common factor. Okay, when a polynomial is factored fully, there means that there's no monomial or polynomial or anything else that they have in common. You cannot factor out anything else. If you look at this example right here, this is not fully factored because these two terms both have an x in common. Okay? So here's how we do this. We look for the common factor first. So I look at 8, 2, and 16 and say, what do they have in common? Well, the greatest common factor is a 2. Then I have x to the 5th, x to the 4th, x squared. Okay, the largest number of x's that they have in common is x squared. So this is my GCF, my greatest common factor. One way to do this is to take each one of these terms and to break it apart so it's got a 2x squared. And then what times 2x squared will give you 8x to the 5th? Well, that would be a 4x to the 3rd. Okay, I need a 2x squared here. Let's put this in parentheses like this. Okay, what times 2x squared will give me a negative 2x to the 4th? Well, a negative x squared. All right, and then here, 2x squared. What times 2x squared will give me 16x squared? That's an 8. Now, once you've done that, you see each one of these has that in common. We pull that out front. Pull it out front, and then put what we had to multiply by behind this. So this is going to give me 4x cubed minus x squared, and that's a positive 8. Do you see the distributive property here? If I were to take that 2x squared and distribute it, I would get what I started with. Make sure that whatever you have left in here doesn't have anything in common, and that is factored. All right? We're going to do this one. What do these two have in common? I'm going to say a 2, but I also notice that they have a negative, so it's perfectly okay to pull out a negative 2. All right, x-wise, what's the most x's they have? Just one x. Okay, now, just a minute ago, I broke it apart and factored it out. Another way to do that is to just take these terms and divide them by your GCF. So in that case, negative 14x divided by negative 2x gives you a positive 7. Here, negative 12x squared divided by negative 2x gives you a positive x. Again, if you were to distribute this, would you get, oops, my bad, I wouldn't. See, it's a good thing I went back and checked that. I'm sorry. That is supposed to be a positive 6x. Okay, see, by checking, I got that. Good job. All right, let's do the last one down here. What would you say they have in common? I would say a 2 and an x squared. And sometimes you just do it in your head. 2x squared times what gives me 8x to the 4th? 4x squared. Plus 2x squared times what gives me 4x cubed? 2x minus 2x squared times what gives me 2x squared? 1. You have to have that there. Okay? All right, sometimes the GCF is a binomial, and it's called a common binomial factor instead of a common monomial factor. And you do the same thing. You'll notice that this has an x plus 2 and this has an x plus 2. So you're going to pull that out front. That's going to be an x plus 2. And then what's left over when that's gone? There's a 5 and a plus 3x. And now you've got a binomial times a binomial, which if you were to multiply it out, gives you this. All right, here, what do these guys have in common? That's going to be a b squared plus 1 What's left over when you pull that out? A negative 2b plus, and what is right here, even though you don't see it? A 1. So a negative 2b plus 1. Okay? Two quantities are opposite if you add them together and they get a 0. Doesn't matter what they look like. If you add two things together and you get a 0 for your sum, they are opposites of each other. Being able to recognize opposites is going to help us do some factoring. Okay? So let's take a look here. We've got 5 minus x and x minus 5. And we are saying those are opposites of each other because if you add them together, you get 0. I realize that 5 minus x can actually be written as negative 1 times x minus 5. I'm factoring out or pulling out a negative 1 to make that x minus 5. When I replace the 5 minus x with this, then I can see that these two are the same. Okay, so if I were to factor that out, that would give me an x minus 5, and then that would be a negative 1 right there, and this would be a positive 1 right there. And negative 1 plus 1 is 0, and 0 times x minus 5 is 0, and yes, those are definitely opposites of each other. Okay? All right, we're going to do, the last thing we're going to do here is factor by grouping. When you have 4 terms, you can cut them in half. Okay, instead of looking for something that they all have in common, just cut them in half. What do these two have in common? These two have in common a 2x squared. And when you factor that out, you're left with an x minus 6. These two have a 3 in common. And if I factor that out, I'm left with a 6 minus x. I'd really like these, what's inside the parentheses, to be the same, but they're opposites of each other right now. So what I'm going to do is I'm going to make this a negative, and that's going to make that a negative, and that's a positive. This is actually the same thing as x minus 6. So now they both have an x minus 6 in common, and what's left over? A 2x squared minus 3. All right, let's try this with the next one. You should probably pause the video and do it yourself first. Okay, this is going to give me an x squared, which is going to leave me with a 2x plus 1. Here I'm going to pull out a negative 3, which is going to leave me with a 2x plus 1. What's inside the parentheses is the same, so that's 2x plus 1. What's left outside the parentheses is an x squared minus 3, and that is factored.